Okay, last night's homework was about probability. Anyway, tomorrow's quiz, I posted a practice quiz on the website. Did you guys look at it yet? I made it super easy. So now is your chance to get 20 out of 20. Anyway, we're gonna go over it after we finish the lesson today. This is your chance to raise your grade. Okay, questions on the homework. So what did you have to do up to?
69.
Oh, to 69. 17 to 69. So some of these problems, the key thing is you gotta know when to add and when to multiply the numbers. And remember, when you see the word and, like what's the probability of this and this happening? That's when you multiply. If you see the word or, that's when you add. Like what's the probability of this or this happening? So no questions? I can't believe that. Actually, I'm looking at these look pretty easy. And then I'm not going to post the practice test on the website, I'm just going to make copies for you. I have to like draw it some things, that's why. So I'll just pass it out tomorrow. Okay, no questions then? No. All right. So today, if you look over there, we're going now back to chapter 13. 13.5. Basically, it's the binomial theorem. Now, before I discuss the binomial theorem, remember, this notation, this is for combination, right? NCR, that's like the combination of n things taken r at a time. Or some books write it like this, what am I doing? Combination of n things r at a time. Which way does your book do it? You guys the one doing homework. Or remember, and I also told you, when you get to pre-calculus, then we write it like this. But either way, it means the combination of n things taken r at a time, or we just simply call it n choose r. And then everybody knows the shortcut for computing it, right? Because tomorrow you're going to have to compute these numbers. Okay, so let's start at the very beginning from algebra 1. How do you expand x plus y to the 0? That's 1, right? Anything to the 0 power is 1. How do you expand x plus y to the first power? Come on, this is a dull people. X plus y, right? Gorilla to the first power is gorilla. How do you expand x plus y to the second power? This is algebra 1. X squared plus 2xy plus y squared, correct? Okay, and then in algebra 2a, we learned how to expand x plus y to the third, which is, you guys remember? Come on.
X plus y times x squared.
X cubed plus, really? 3x squared y plus 3xy squared plus y cubed. Does that look familiar? See how though? See, when you expand something plus something to the something power, see like squared, see how the first term is squared, x gets squared, and then what happens? The power of x goes down by 1, and then the power of y starts going up by 1. And then in the next one, see how the next one will be x to the 0, which is 1, and then y squared. And that's the pattern in this too, look. This is like x to the third, y to the 0. The power of x goes down by 1, see how 3, 2, 1, 0. And the powers of y go up by 1, 0, 1, 2, 3. And the two powers always add up to 3 over there. But the question is, where did this 1, 3, 3, 1 come from, or the 1, 2, 1? Where did it come from? Well, that comes from when you multiply it out and you gather the like terms, right? Like after algebra 1, like when you first learned it, this was hard, but now like this is nothing, right? X plus y squared is x squared plus 2xy plus y squared. when you come out of algebra 2a, this is supposed to be nothing too, but I guess it's something. But then when you come out of algebra 2b, what about x plus y to the fourth or x plus y to the fifth? How do you expand that? What do you do? Okay, well, let's do this. What's the first term going to be if you follow the pattern? X to the 4, then it's going to be plus something, and then the power of x goes down by 1, what? X cubed. And then now the power of y starts going up by 1, because that's like y to the 0, y to the 1. And then what's the next one going to be? Something times x squared y squared. Come on, the powers of y going up. You guys can add 1 and subtract 1. And the two powers always add up to 4. See, 4 plus 0 is 4. 3 plus 1 is 4. 2 plus 2 is 4. They always add up to 4. So what's the next one going to be? Something times x to the, no, the powers of x going down by 1. What's after 2? 3, 2, 1. And the powers of y are going up by 1. Y third. And finally, plus something x to the 0, which is 1, y to the 4th. Now, all we have to do is figure out what these numbers are that are over there. Well, one way is, okay, what if you were in a Turkish prison, and the only way that you could leave is if you have to multiply this up. Well, you have all day, right? You just go x plus y times x plus y times x plus y times x plus y, right? That's what fourth power means. And so you multiply that times that first, everybody can do that. Then you take that result, multiply it by that. Then you take that result and you multiply it by that. But then what happens if you have like x plus y to the 10? Or you guys are like class of 2017? What if 2017 power then? Then what? You don't want to do this, right? So is there a better way? Yes. So to get these coefficients, anybody? Anybody want to impress me?
Is it 4?
Yes, it is 4. In fact, oh, this one is 4 too. What about this one over here? No, it's not 4.
It's 8?
No. You guys are just guessing. How do you get these numbers?
Because it's because that one is like 3, the third power, so it's like 3.
Oh no, no. Okay, have you ever heard of Pascal's triangle? Where did you first hear of Pascal's triangle? Right now? Okay, let me show you how to construct Pascal's triangle. Pascal's triangle, you start with a 1 on the top, and then a 1 and a 1. And basically, you have 1s on the outside like that. To get the numbers inside, though, what you have to do is add the 2 numbers above it. See, like 1 plus 1 is 2. You just add the 2 numbers above it. So like over here, what's 1 plus 2? What's 2 plus 1? 3. So as long as you can add, you can make Pascal's triangle. Okay, how do you make the next row of Pascal's triangle? You put 1s on the outside, and then you go 1 plus 3, 3 plus 3, 3 plus 1. What? 3 plus 1 is 4. Hey! Is there something special with those numbers? Try to compare those numbers with what we just did here. Oh, Mr. Park! These numbers are the coefficients when you expand x plus y to a power. Did you guys ever, no teacher ever told you that? Oh my goodness. So, if you want to expand x plus y to the 4th, then what you do is you go to the 4th row of Pascal's triangle. Now some of you going, wait, isn't that the 5th row? Just look. 1, 2, 3, 4, 5. This is the 5th row, Mr. Park. You're crazy. No, this is the 4th row. That's because we call this first row the 0th row. You know why we start with 0? Because it corresponds to x plus y to the 0. So if you want to find the coefficients for x plus y to the 4th, you just go to the 4th row, and these are the coefficients. So you just fill it in. 1, 4, 6, 4, 1. And that's how you expand x plus y to any power. Instead of just multiplying it out like a madman. So now that I've given you the secret, how do you expand x plus y to the 5th? Well, first of all, look at the powers of x. What is it going to start with? X to the 5th. And let me just ask you this. How many terms will there be? If I were to expand this, how many terms? There's going to be 6 terms, right? Because look, to the first power get 2 terms. To the second power get 3 terms. to the third power get 4. It's always going to be one more. So when you go x plus y to the fifth, there should be 6 terms, okay? So that's the first one. The next one's going to be something, x to the 4. See how the powers of x go down by 1? The powers of y are going to go up by 1. Okay, so what's the next one going to be? Something, Lee. X to the third. Okay, then the next term is going to be something, Hogland.
X to the second and y to the third.
Plus something, who we got? James Sprung.
X, y to the 4.
And of course, the last one will be y to the fifth, right? Yeah, but Mr. Burke, how do I fill in the numbers? You go to Pascal's triangle. So, since I'm raising it to the fifth power, you go to the fifth row, which would be the next one right here. So you put 1s on the outside, and you simply just add the 2 numbers above it. 1 plus 4, 4 plus 6, 6 plus 4, 4 plus 1. So that means the coefficients are going to be 1, 5, 10, 10, 5, 1. And that's how you expand it. Isn't that a lot better than going x plus y times x plus y times x plus y times x plus y times x plus y? Yes! Okay, so tonight's homework, they're going to give you something like this, and they're going to ask you to write it out. Okay? But sometimes, the harder problems, okay, x plus y to the fifth. Okay, now let me ask you this. What if I give you x plus y to the, give me a bigger number, like 30? Can we do 30? Or is that too small? Okay, let's do a bigger one. How about 50 then? X plus y to the 50. Now, I am not going to ask you to expand that because how many terms will there be? There will be 51 terms. I'm not going to ask you. I'll probably ask you, like, what are just the first 3 terms? What are the first 3 terms? Good enough. Okay, so if you go down to the 50th row of Pascal's triangle, so Mr. Park, I'm just going to keep making this until I get to the 50th row? You're crazy! Yeah, no, I'm not. That's because these numbers are special numbers. Does anybody see it yet? Or did anybody read the book ahead of time? Of course not. Okay, you see these numbers in Pascal's triangle? In the 5th row, you know what these numbers are? These numbers are 5, choose 0. 5, choose 1, 5, choose 2, 5, choose 3, 5, choose 4, and 5, choose 5. So the number is in Pascal's triangle are simply the combination numbers. So now, we don't even have to make the triangle anymore because those numbers are, so here we go. If you want to expand x plus y to the 50, okay, what's the first term going to be? X to the 50th power, right, if you follow the pattern. Then the power of x comes down by 1, so it's going to be something times x to the 49, and then y starts going up. And what's the third term going to be? Something times x to the 48, y squared, right? Those are just the first 3 terms, that's all I'm asking for. You know what? I'm going to ask for the first 4 just for that. So the next one's going to be something times x to the 47 y cubed. Okay, that's the first 4 terms. That's all I want because, like I said, 51 terms is unreasonable. Yo, Mr. Burke, how do we figure out the numbers? Well, I just told you. If you went to the 50th row of Pascal's triangle, what would the numbers be? What would the first one be? 50, choose 0. 50, choose 1. 50, choose 2. 50, choose 3. Those are the numbers. You don't have to make the triangle. And then now you just have to compute it. Okay, so let's do this. What is anything choose 0? We learned from our previous homeworks. 1. Is 1. And you can see that, right? All the numbers on the outside are 1. Anything choose 0 is going to be 1. So 1x to the 50th plus, what else did we learn from our homework? Anything choose 1 is, are you serious? If you have seven candy bars, how many ways can I select one of them to put in my lunchbox? 7, right? So anything choose 1 is anything. Are you guys sure you're doing your homework? Okay, now 50 choose 2. Now how do you compute 50 choose 2? Should I use the formula? Or should I use Mr. Park's shortcut method? Yeah, the shortcut. You should know this for tomorrow too. How do you compute 50 choose 2? What was the shortcut? You put 2 times 1 in the bottom, and then 50 times 49 on the top, right? Remember, you have 2 numbers on the bottom, you gotta have 2 numbers on the top. 2 goes into 50. You know what? I shouldn't have picked 50. I should have picked, but that's okay. You guys can handle it. What's 49 times 50? I mean 49 times 25. Go. 5 carry 4. 8 carry 1. 5, 2 carry 1. 1, 2, 2, 5. I'm afraid to even go to the next term. How do you compute 50 choose 3? Well, if you use the shortcut, what is it? 3, 2, 1 on the bottom, and then 50 times 49 times 48 on the top. Now, how the heck am I going to compute that? Well, 3 times 2 is 6. 6 goes into 48 8 times. So what is 8 times 49? 49 times 8 is 2 carry 7. And then you got to times it by 50. So I times it by 5. 0 carry 1 carry 4. But then you got to add a 0 to that. 19,600. See, I told you all the numbers can be less than a million. There you go. Those are the first 4 terms. Don't worry, I won't make this number 50 power on the test. It'll be like 20 or 30. 20 would be good, yeah? Because then when you divide it by the 2, you get a 10, which makes it easier to multiply. Okay, so what other kind of problems you can see on tonight's homework? Okay, before we go on to the next problem. What if I were to ask you, if you were to expand x plus y to the, give me a smaller number, how about 11? How many terms will there be? There will be 12 terms, okay? What is the 10th term, say? No, what is the 9th term? So if I were to expand it, I would have 12 terms. What is the 9th term? So do I write them all out and then box the 9th one? No, there's a pattern. Okay, look at this pattern. If you expand it to the 50th power, here's the first term. Here, I'll point to the number you should be looking at. Here's the first term. Here's the second term. Here's the third term. Here's the fourth term. Do you see a pattern?
It's going to be x to the third and y to the sixth.
Okay, so the first number is going to be 11 choose, if I want the 9th term. What? Okay, look. Here is the first term, the 21st term. Here is the second term. Here is the third term. Here is the fourth term. So, if I want the 9th term, what number do I put here? 8. It's always going to be 1 less. And also, did you guys notice? Hey, this number here is the same as the power of y. Look, 2, 2, 3, 3, 1, 1, 0. Of course, that's like y to the 0, right? So, you already know that that number could be the power of y. And you also know that these 2 powers always are going to add up to, look, these 2 powers always add up to this number here. So these 2 numbers are going to add up to 11, so what? It's got to be 3, and that's how you figure it out. Instead of writing out all 12 and then boxing the 9th one. And then you just got to compute this now. How do you compute this? This is good practice for tomorrow's quiz. How do you compute 11 choose 8? Well, 11 choose 8 is the same thing as 11 choose. Have we forgotten already? 3, remember? And why do you want the smaller number on the bottom? So you can go 3 times 2 times 1, and then 11 times 10 times 9. Isn't that better than putting 8, 7, 6, 5, 4, 3, 2, 1, and then 11, 10, and then? Yeah, you want a smaller number on the bottom. And then let the canceling begin. 3, 5, 15 times 11 is? 165. So 165 x cubed y to the 8th. That's how you do it. See, there's always patterns. In fact, some people describe mathematics as the science of patterns. I don't, but some people do. Okay, last example. What if you have x plus y to the 20th power. What are the last three terms? So write the last three terms. We won't even do 4, we'll just do 3. Okay, now if you were to expand this, there would be 21 terms. There's no way you want to write all 21 and just box the last 3, right? So if we go backwards now, okay, so we want the last 3. So if I went backwards, what? What's the last term going to be? 20 choose 20, right? Because we all start with 20 choose 0 on this side, right? And it keeps on going until you get to 20 choose 20. Remember, whatever number that is, that's the power of y, and the 2 powers got to add up to 20, so it's like that, right? Or you don't have to write the x if you don't want to. What's the term right before this going to be? 20 choose 19. Whatever number is there, that's the power of y, and then the 2 powers got to add up to 20, so that has to be a 1, right? And then what's the term right before this? 20 choose 18. X to the something, y to the something, but whatever's there, that's the power of y, and the 2 powers got to add up to 20, so that's got to be 2. Right? It's just a pattern, that's all it is. And then now you just compute. Okay, let's start with this one. 20 choose 20 is the same thing as 20 choose what? 0, thank you. And anything choose 0 is 1, so what is this? What is 1 times y to the 20? Nagami. You cannot wait 2 minutes. Look. Like the last time I used the bathroom was last night.
That's not that long.
Really? It's gory. 20 choose 19 is the same thing as 20 choose 1. But what did we just learn? Anything choose 1 is anything. X to the first, y to the 19. Don't write x to the first now. Just write x. Okay, now 20 choose 18 is the same thing as 20 choose 2. How do I compute that? 2 times 1 on the bottom, 20 times 19 on the top. See, this is why I told you 20 is good, because look, 2 goes into 20 10 times, and anybody can multiply by 10, I think. 190 x squared y to the 18. There you go, that's the last 3 terms. Just gotta go backwards. Oh, I get it now, Mr. Park. 20 choose 0 is the same thing as 20 choose 20. 20 choose 1 is the same thing as 20 choose 19. So that's why Pascal's triangle, did you guys ever like make connections like that? That's why it's symmetric. These numbers are all the same like that. Because this and this are the same coming in. And you know what another pattern is? No, I'll just show you. Nope, I won't even charge you. What happens when you add the numbers in Pascal's triangle? Okay, look, in the 0th row, if I add that number, what do you get? 1. Okay, in the first row, add those numbers, what do you get? In the 3rd row, add those numbers, what do you get? That's not the 3rd row, that's the 2nd row, what do you get? Okay, add the numbers in the 3rd row. 8, 4, 16, here's the 5th row, add up those numbers. Whoa! What? What are these numbers? Yeah, exactly. These are the powers of 2. This is 2 to the 0, 2 to the first, 2 to the second, 2 to the third, 2 to the fourth, and 2 to the fifth. Oh, so if I went to the 50th row of Pascal's triangle, what if I did? What would happen if I add up all those numbers? What would you get? 2 to the 50th power, which is something really, really huge. Okay, that's just for no extra charge, something neat. Okay, so tonight's homework, it's pretty easy. This is not difficult. Okay, last thing I want to do, we still could finish early. I want to do the practice quiz in class, because I want everybody, I made it easy. I want everybody to get 20 out of 20 tomorrow. So we can do it together now. Because otherwise, we stop class now, what are you going to do? Sit over here and fool around. What you guys do? So what, next, in trigonometry, do I get you guys as students, or do I get a new, fresh batch of students?
Fresh.
Yeah. Yes. Okay, number 1. Given two sets A and B, so this is the Venn diagram problem. The number of elements in set A is 15, the number of elements in B is 12, and the number of elements in A intersect B is 8. Compute the number of elements in A union B. Okay, now, when you make a Venn diagram with just two sets, so that means tomorrow only gonna have 2, but another test gonna have 3 now. But we'll do the practice test. So there you go. You draw it like that. This is the Venn diagram. And which part do I always fill in first? The one in the middle. Do they tell you how many things are in the middle? Yeah, right there. The number of elements in A intersect B, that means where they overlap, is 8. So you always fill in that section first. Then it says the number of elements in set A is 15. Everything in here has to add up to 15. So if that's 8 already, then what do I put here? 7. Do not put 15 here now, because that would be a bad error tomorrow. Then it says the number of elements in B is 12. Everything in here got to add up to 12. So if that's 8, what is this? 4. So how many elements are in A union B? That means in A and B together. Well, you simply add these numbers up here. What's 7 plus 8 plus 4? Oh gosh. What's 15 plus 4? Okay. Do I have to? You guys. Number 2, a code. Oh, it's a code. It's like a license plate. So this is a permutation. Okay. A code is made up of a letter followed by a non-zero digit followed by a vowel. So you can make the slots. We're going to use the multiplication principle. How many codes are possible? So all you got to ask yourself, how many choices do I have? Now the first one has to be, I forget already, a letter. How many choices do I have if it's a letter? 26. The next one is a non-zero digit. So any digit except 0. 9 choices. And then followed by a vowel. Very good. Everybody knows there's 5 vowels? You know, because I remember the last time I taught Algebra 2B, somebody said, yeah, but isn't Y sometimes a vowel? Like in the word bicycle, doesn't it act like a vowel? Yes! Look, I had the D- in English. You can barely spell it. Y is not a vowel, but it acts like a vowel in this word. I learned that in 2nd grade.
Wait, what do you mean?
It's not a vowel, it's a consonant, but it acts like a vowel.
Because they have a song and it's like they name the vowels and then I think it goes and sometimes Y.
Oh yeah.
And so
See.
it probably throws like some people off.
Yeah, so that's why I'm telling you, Y is not a vowel, it's a consonant. Okay? There's only 5 vowels, because I don't want you guys to get confused. And so now, okay, so tomorrow, if you write this down, you're going to get all the points except 1. Then you have to compute this number. So how would you do this? 45 times 26. Can you guys handle that? 0 carry 3, 0 carry 1, 0 7 1 1. Can or can not? I hope you can. No calculator tomorrow. All the answers are less than a million. Okay, number 3. Look how easy this problem is. How many ways can 6 people be arranged in a row? Now, you want to give them names? Alfredo, Bernardo, Carlos, Diego, Eduardo, Fuego. Now, you guys already know what's the answer without even doing any work. 6 factorial, right?
Yeah.
But if you want to make the slots, okay, here are the 6 seats. How many choices do I have for the first seat? 6. Once that person sits down, that's the same thing as 6 factorial. And do we have that memorized yet? 720? Or we gotta go like this, okay. That's 6. 6 times 4 is 24. 24 times 5 is 120. 120 times 6 is 720. That's why in pre-calculus honors, we memorize all the factorials up to 10 factorial. Because when you do permutations, combinations, and probability, it comes up a lot. But it's up to you. Okay. Just do it the old-fashioned way. Okay, how many 4-digit whole numbers are there where no digit is repeated? And look, I told you right there, 0 cannot be the first digit. So we're making a number, so is that a permutation or a combination? It's a permutation. The order is important, so you can make the slots like this. Okay, so the first digit, how many choices do I have? Now, if you need to, write the digits out like this. It says, how many 4-digit whole numbers are there where no digit can be repeated and 0 cannot be the first digit, which we already know. So how many choices do I have for the first digit? You have 9 because you can pick anything except the 0. You have 9 choices. And if you want to do this, go like this. Okay, let's say I picked the 4. Now how many choices do I have for the second digit? 9, because now you can use the 0, right? Okay, let's say it was the 2. How many choices do I have for that one? Because you cannot repeat any digit. 8 and then 7, and then you just multiply those numbers. And for some of you, this is the hardest part of the problem, right? 81 times 56. That's the way I would do it. I don't know how you guys do it. 648, 540. Woo! 6, 3 carry 1. So 4536 is your answer. Yeah, just leave it there. Anyway, how many of you came up through Iolani? So Mr. Chun gave you the worksheets where you have to multiply 6-digit number by 6-digit number, right? Remember? You guys should be good at that then. Okay, next one, number 5. How many 9-letter words can be formed using the letters of the word beekeeper? Now, if these 9 letters were all different, then what would the answer be? 9 factorial, right? Just like 6 people seated into 6 seats, right? 6 factorial, right? But remember, what do you do when you have repeated letters? Anybody remember what to do? Since I have 5 E's, how do I adjust for that? Because if you switch these 2 E's, it's still the same word, right? Beekeeper. So how did we adjust for it if there's 5 E's? You divide by 5 factorial. And then go 1b, so divide by 1 factorial. Yeah, you can, but 1 factorial is 1. You don't need to do that. And then there's no other repeated letters, so that's it. Okay, and then you got to compute it now. So what is 9 factorial? 9, 8, 7, 6, 5, 4, 3, 2, 1. Divided by 5 factorial. 5, 4, 3, 2, 1. Cancel, 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 cancel. So what's left? 72 times 42. Can do? 144, 8, 288, add 4, 2, carry 1, 0, 3024. And then finally, the last problem. How many ways can a committee, oh, I see the word committee. So when you see the word committee, what are you thinking? It's a combination. The order is not important, so that means you cannot do the slot method. Slot method means there's an order to it now. Okay, so how many ways can a committee of 7 be selected from 10 people? Well, isn't the answer just 10 choose 7? Or would you rather write it like this? 10 C7, or the way your book does it, C10 comma 7? It doesn't matter. I'm used to teaching pre-calculus, so I always like that. Plus, it looks more mathematical, yeah? Yeah, when you do this, you're smarter. Impress your friends right there. Anyway, how do you compute 10 choose 7 then? What do you do? That's the same thing as 10 choose 3, remember? You want that smaller number in the bottom. So how do you compute that? 3 times 2 times 1 in the bottom, and then what's on the top? 10 times 9 times 8. 3 goes into 9 3 times. 2 goes into 8 4 times. So what is 12 times 10? 120. So that tomorrow's quiz, 5 minutes I think it's going to be. Now I'll give you 1 minute for each one. I'll give you 6 minutes. So hopefully this will be a 20 out of 20 for everybody, unless you have problems carrying. All right, we're done. So we got 20 minutes remaining.